Welcome to Datadog Illuminated. Your company runs on data. Data gets generated somewhere. It flows from one system to the next, to the next, to the next, to the next. It gets transformed along the way, usually in several places, and eventually that data becomes something important. What that something important is, maybe the number on your dashboard, maybe it's a recommendation that your app makes to your customers, or maybe it's a line item in your billing invoice. Data can touch many teams and many services, so when bad data gets introduced, the results can be catastrophic. Something breaks upstream and it breaks all of the downstream services that depend on that data. Or worse, nothing looks broken and the information that teams rely on just silently fails for hours, for days, for weeks before anyone notices. And the source of the bad data can be hard to find. The tools that move and transform data, they all speak different languages. There's no common standard, or there was no common standard. Spoiler alert. So if every tool that wants visibility into where exactly their data came from had to reverse engineer every other tool, it was a ginormous pain. Don't worry though, OpenLineage is here to save the day. Bum-ba-da-dum. Julien is a principal engineer at Datadog and the project lead for OpenLineage, an open observability standard for data pipelines. He and the OpenLineage community have built a common language for all of those tools so teams can easily see and understand the full picture of how data is introduced into the system, how it moves throughout the system, and how it gets transformed during its journey. I wanted to understand how it works. What is OpenLineage exactly? Is it a specification? Is it library? Is it integration? Is it software? What is it? Do you need to refactor your whole system in order to use it? Is the work of adopting it worth all the benefits? What even are the benefits anyway? Don't worry, Julien has all the answers. Let's do this. All right, I'm here with Julien Le Dem. Will you introduce yourself, please?
Hi, Whitney. I'm Julien. I'm a principal engineer working on the data platform here at Datadog. I'm also the project lead for OpenLineage at the LFAI Foundation.
Will you tell me, Julien, at a very high level, what OpenLineage is?
At a very high level, it's a common observability framework for data pipelines.
Why do pipelines need a common observability framework? What problem is being solved here?
So, as a data engineer, you're responsible for producing data in some form. Maybe you're producing dashboards, producing data for others to build dashboards or data-based products and things. Usually you have a good understanding of what data you're reading, what data you're producing, and maybe within your team, you understand how things work, how you depend on each other. But as soon as you go beyond that, beyond your bubble, it can be pretty difficult to understand what's happening, right? Like where the data you're consuming is coming from, how it's changing, whether the team who owns it is changing things. And sometimes even downstream, you don't know who's consuming the data you're producing. That creates a lot of friction. Whenever you change something, you create the possibility of breaking something downstream.
Imagining what you're saying, we have different organizations or different teams, and they all understand maybe within their own team how data works.
Yes.
But what's happening is like maybe this is going over across into another bubble in this data org. And maybe this is also going down here into this data org. When this happens across tens, hundreds of teams and uncountable data sources, what goes wrong flows downstream. It affects all the data that comes after it. If this arrow that's transforming data does something incorrectly, now it's affecting this team, now it's affecting this team, and then God knows what's downstream from that.
So in this example, like org A, we made a mistake, right? Like this data set at the end of this little arrow is broken. And we fix it. We make a new version of it. But the bad data propagated to other teams, and maybe they consumed it the first time it was produced, but they're unaware it's been corrected, right? So it's part of the problems where sometimes the bad data is propagated and it stays bad downstream and nobody's aware of it. I've seen cases where Oh, billing has been wrong for months. Which obviously is bad when you have to issue reimbursements to your customers or something. If you find out only when someone complains, that's not a good look. A lot of things like that come from the lack of visibility. So that's where, we talk observability for data pipeline. One of the first use cases is getting more visibility into that. And you can use it for various things like impact analysis, which is I change something. Am I able to tell who is going to impact and how? Or the other way around, like as me consuming from others, understanding what's happening upstream, right? Being able to verify or talk to the right team who owns the change upstream to correct things or prevent things from happening. That's one of the problems. Like there are also a lot of compliance governance issues. So this is I describe more the data reliability, data quality aspects. There's also compliance governance issues where if you have your user's private data somewhere, you need to make sure it's only being used for the appropriate use cases, right? They should not be automatically sent to the marketing team for sending ads if the people didn't opt out for it, for example, or things like that. So there's a bit of understanding where the data flows to respect privacy laws, for example, like GDPR. Some industries where you have like regulations, like in banking, you need to understand how the data flows from your building reporting on transactions from all the transaction data. So you need to be able to prove that you understand how the data flows and that it's correct, right? Like your reporting is correct.
So the teams are isolated from each other so that there's just no understanding of upstream or downstream. When bad data happens at Propagates, and one thing you said from yours is you might not find out for months. If it's not something that's breaking something, it could be a problem that happens a long time, and then it's especially hard to discover.
Yeah, when something's not working, right, you can tell, it's broken. When something sends wrong data, it's way worse, right? Because that can stay unnoticed.
Broken data isn't necessarily something that's going to cause an alarm. Before the stream, what I understood about OpenLineage is I thought it had something to do with like a common language for data to move around in, as opposed to before. Is that correct?
Yes. Another source of complexity is the data ecosystem is fairly fragmented. Different teams might be using different tools, right? Like if you do BI, you might use SQL, data warehouses. If you are in the ETL department, you might be using Airflow, Spark, like other types of tool for transformation. You might be using machine learning tooling somewhere else. They kind of all speak slightly different languages. And so understanding the dependencies across everything can be fairly challenging if you're trying to extract lineage for a bunch of things. So having a common representation that everybody adheres to, lineage simplifies significantly the problem, right? What we'd see before is you would have various vendors making solutions, maybe for compliance, maybe for governance, maybe for data quality, data reliability. And each of them would go reverse engineer all the data tooling you would have to extract lineage and get this visibility. So that creates like a very complex ecosystem that's very brittle too.
Yeah, I was picturing like finding upstream data sources, like where something broke is hard. I was picturing it was hard because of these isolation bubbles, which is true. But it's also hard because these arrows each represent possibly different languages or different transformation technologies. So there's like an element of reverse engineering to it also.
Yeah, like different teams would use different tools. That's why within their bubble, a team might be comfortable with the tooling they're using, right? They know how to troubleshoot their SQL queries in their warehouse, but they may not be able to understand like how exactly the other tech stack the other team is using for ETL exactly is working, or like why it's not working. And sometimes it's just like use different schedulers or different things, and they don't have visibility in what the others are doing.
Very quickly, you said ETL, which I just want to shout out very quickly, is extract, transform, load, I believe, right? Another way of seeing transferring data. The other thing is we've been saying data lineage a lot already, and I think it would be great to define what that is and get it on the board. What do you think?
Data lineage is understanding how a particular data set is derived from other data sets, right? And in particular in this ecosystem, it's also about understanding the thing that does the data transformation in between. In those arrows of this, you will have a job which might be a SQL query, like for example, a create table as select. So you're deriving a data set from other data sets, right? Or running a Spark job, you read data set and you write using data frame and you write an output, right? There's different ways you can do that. And Lineage is about capturing where this data is coming from, right? It was derived from another data set using a specific transformation. There's this like kind of static definition of lineage, right? This data set depends on those other data sets, but there's also a dynamic aspect to it, which is how often it's updated, when the logic of the transformation changes, and keeping track of that as well. Because usually this is kind of a living graph, right? People are always either building new transformation, evolving their models. So there are lots of things that are changing. And whenever something changes in this graph, it impacts everything downstream of it, right?
Yeah. Data had to come from somewhere. So data lineage captures like where it came from in the first place.
This is correct.
Data is moving around the system a lot. And so that's being captured too. But it's not like they're sending data like this exact SQL table and then they're using this exact SQL table. It's often being transformed as part of these arrows too. Right. Not just moved, but transformed.
Yes. True.
And that's also being kept tracked up because maybe that's where the error is being introduced. So data lineage is keeping track of all of those things.
Sometimes, depending who you talk to, you get a different notion of lineage, right? Because there's this notion of lineage of this data set is derived from this other data set. But I think in the context of OpenLineage, we often talk about operational lineage, which is not just understanding that this column is derived from those columns or something, but also understanding the process of deploying a job that runs at a specific interval. You might have a schedule and connecting it to the changes. Maybe there's a Git repository where you make your changes that gets deployed and that runs, and then you have an Airflow schedule and it runs every hour to updating the data, right? So keeping track of the operational details as well. So you know whether your data is fresh and you know if a recent change to the job that produces the data might have impacted the data quality.
So what I'm hearing is this is absolutely true, but also the simplest possible way to explain what data lineage can be in terms of all the details that can be captured as part of data lineage.
Right. I think there's different perspective. You can look at it from a pure data notion. Columns are derived from those columns. And then there's a more operational perspective, which is like, well, the data is derived because someone wrote code that is being deployed and that's running regularly and keeping it up to date, right? So it's kind of, this whole angle is also important, especially from an observability standpoint, right? And a reliability of data.
So with all of that, I think I would like to finally directly talk about OpenLineage. What is it?
So OpenLineage is a few things, right? So we said open, I think it's a common observability framework, but it's important that it's open, right? Like, hence the name. The first thing it's a specification that specifies a standard way for presenting a lineage independently of the complexity of the various tools you're using for transforming data. It's a bunch of JSON schemas that describe metadata on how to represent lineage. And it also comes with libraries and integrations to make it easy to expose or consume lineage in that representation, right? So libraries make it easy in multiple languages to consume or produce lineage. And integrations provide integration for popular projects. For example, Spark, right? Like there's an OpenLineage Spark integration that you install a plugin in your Spark jobs and it's going to produce lineage in OpenLineage format. There used to be an OpenLineage Airflow integration in the OpenLineage repository, and this was merged into the Airflow project itself. The end goal is to make sure the OpenLineage support is in each of those projects that can produce lineage. That's how we simplify the whole problem of collecting lineage. That way it's tested with the project and it's like a first class feature in the project saying any data transformation job should expose lineage of what it's doing.
OpenLineage is an open observability framework for data processing. My understanding too of OpenLineage is because it's open source, and then it's multi-vendor and it has pretty wide adoption. Is that true?
Yeah, the point is not that we need a better standard and then it's going to encompass everything, right? The point is we need something that we all work on together, right? So we started OpenLineage by involving as many of those vendors we need lineage as we could so that we can build adoption, because the standard is only as valuable as the size of the ecosystem
it's
that you
so true.
right? That's because that's the value of standardizing how we represent the lineage is then you can integrate, instrument your jobs once, and you can use many tools, right? And you could use multiple tools too. You might have a tool that's more focused on data reliability and data quality, and you can have a tool that's more focused on compliance.
So how does OpenLineage fit in here?
You get all those little squares, right? Which basically representing data set that are produced by a data transformation, right? So what it's doing is instrumenting all of those things. So you can send lineage events, or we capture them as events, lineage metadata about all your data transformation to a central repository. So you can actually build that lineage graph, right? So each of those will instrument its input and its output, right? I read those data sets and I produce this data set.
Okay.
And send metadata about it, right? What was the schema of the data set I read at the time I read them? What is the schema of the output? What's the version of the package I'm using?
Is each of the green squares sending an event to the data lineage repo, which we'll talk about those events shortly? Or is it more the bubbles sending the events to
it's each square.
In addition to sending it wherever it's going operationally within the
right. So
across org.
Yellow arrows are actually exchanging data, right? And those little red box you're sending, it's metadata about what happened, so that we can keep track of all the changes that happen, in what order they happen, how they influence each other, what's the impact of a change. So it's capturing all of those little things.
Like the repository itself, is that a big part, or is OpenLineage really about these events?
OpenLineage is about the events, right?
Okay.
And OpenLineage is about the instrumentation and define the content of the events. Data lineage repository, that's where you can have multiple tools. You can either send it to one tool or to multiple. The idea is you can get your instrumentation done once, and then you can use different tools that will leverage understanding how everything depends each other, right? Maybe on the far right, you have a dashboard that's really important, and you want to make sure that it gets updated in a timely manner and with correct data. And that way you can keep track everything that's upstream of it, thanks to this lineage, to make sure you have high quality dashboards. Or you can look at this the other way around. If you're interested in compliance with GDPR and you're curious where your user private data is going, you could follow, the arrows the other way around, right? Let's say we have user data. Who's reading it? And how do we enforce that only the teams that are supposed to be reading this data are reading it, right? And verifying this, right? So
if we have an error introduced at any point, we can see exactly where it happened.
Right. You can use it to enforce policies. You can use it in different ways. Part of the OpenLineage philosophy is instrumenting things as they're running, because sometimes people look at lineage after the fact. But when you look after the fact, there's a lot of what was happening that you may not have captured. So that's why the OpenLineage integration, usually they come as a plugin to the job, right? Because they instrument the job as it's running, or it's really from an observability standpoint, right? Like thinking from an observability angle and very operational angle, we instrument the job as it's running. So we can capture precise metadata when it started, when it ended. You could have even performance concerns, right? Like when the job is running, you can capture how much CPU it's used and how much it will cost, right? If you want to interested in those use cases as well, you can also use it that way. And instrumenting and runtime gives you a lot of granularity in what you can capture.
So the runtime piece is an important piece of it.
Right. So we call them run events. The basic integration is you get two events. There's a start event and the end event, right? So when the job starts, you get a start event that may send some information about where it's reading from, where it's writing, what are the schemas of the data set. And then when it's finished running, you will have an end event that will tell you that the job is finished running, if it was successful or not, how many rows it wrote, right? This kind of information. So that captures the beginning of the end of a run. And a run is attached to a job. The job is the recurring thing, right? Like you may have multiple runs for a job. For example, it could be a airflow job, for example, and that runs every hour. So every hour you will have a new run with a start and an end, right? And for the same job. The job is the actual logic that transforms data. So it could be equal, query, It could be a Spark job. It could be a Python script. This is the thing. The job is the thing that transforms data, and that will have multiple runs, right? Maybe you run it every hour or something.
Okay, so a job is a task and a run is like an instance of that task. A job can have multiple
That's
runs.
correct.
Okay.
Yes.
Okay.
And then it has input data sets and output data set. Like, for example, if you have a SQL query that does create table A as select from joining B and C are the input data set, A is the output data set, right? So you have this graph of dependencies where you always have a job reading from data set and writing to data sets. So it's kind of a bipartite graph or job to data set, right?
Yeah. So the data set, it's just the data.
It could be a table in your warehouse. It could be files in a blob storage. It could be an iceberg table. It could be a snowflake table. It could be files. It also captures streaming. So you could also be a Kafka topic, for example.
So one of these run events that's coming from an instrumented file, it's capturing a reusable job and then the instance of that job and then the actual data that was.
And the inputs and outputs, yeah.
Data in, data out.
So a job is always connected to its inputs and outputs.
And you said earlier, the specification was JSON schema. So is this like JSON?
Yes, it is JSON, and it's using JSON schema. This is the core of the model, right? And the core of the model is on purpose very simple, right? You have this job and reads data sets and writes to data sets. And this is the core that collects lineage. And then there's this notion of facets, which helps you put more metadata, more optional metadata to this, right? Like, because a job, if it's a SQL query, right, you have a facet that will capture the query profile when it's done running, right? So that's how, for example, I was giving the example of cost management or how long it took. You will have a facet that if it's a SQL, there's a SQL profile, query profile that capture runtime characteristics. You will have another facet, which is what was the version of that job, right? Like, you could capture the Git SHA of that specific version. So you can track if you have a change in the quality of the data, you can correlate that with what version of my code it was that generated it. On the data set, if it's a table, you will have a schema facet. Depending on the type of data set, they don't all have the same metadata. If it's a table, they will have a schema, what are the columns and their types. If it's a Kafka topic, it will have a Kafka topic name, and you can capture metadata related to that. If it's an iceberg table, we will capture what snapshot of the table you consume. So the facets are something that enables specializing the metadata and capturing optional things, right? Like, depending on the integration, you might capture also column level lineage, right? Going beyond just the dataset input and output, but knowing that this output column was derived from this input column in that input dataset, right? Being more precise. That's usually it's important for governance, compliance as well, right? Like, because if you have user private data, not all the columns are of the same level of protection, right? If it's PII versus not.
Yeah.
You want to make sure you know whether certain columns go somewhere else or not, for example, right? So it becomes important to have that granularity.
So we talked about different frameworks and different transformation tools and different things being used to move data around. My understanding, and tell me if I'm getting this right, is that a facet is a standardized way to talk about these different types of things so that we can correlate metadata between them all. Is that
right? So because, yes, you have the generic model of jobs and data set, and the facet lets you specialize and gives more metadata that's more specific to that specific type of job or data set. That's what enables us to have a general understanding of the lineage graph independently of what tooling you're using, but at the same time being able to give specific metadata depending on what environment you're in, what tooling you're using.
So it's like a metadata spec that's specific to a technology.
Right. So at the same time, you have a high level lineage dependency, right? You understand dependencies independently of what you're using. But when you zoom in and you're trying to troubleshoot something, you have more specific, detailed metadata about what's happening. Right. So this is the intent, right? You can zoom in and actually understand the specificities of what the job is doing.
So we're talking about this at a very high level and also without any code. So let's take a brief pause and say if someone is a little lost or someone actually gets it but wants to see it in action, where would they go to actually be able to see this in code?
You could send your OpenLineage to Datadog, right? And use Datadog to look at things. But you can also use this other open source project called Marquez, which is a simple, you have a Docker container. It uses Postgres to store the data. Let's say you have your Spark job or you have an Airflow instance, you can turn on the OpenLineage integration and send the events to, for example, Marquez, or you could do that with Datadog as well, our data observability product. But if you like to do this with a free open source project, you can use Marquez. It's spelled Marquez. It's named after the author, Gabriel Garcia Marquez.
Cool.
And the story is because Gabriel Garcia Marquez wrote 100 Years of Solitude, which is a book that follows the story of a family over 100 years, right? And their descendants. So it's a book about lineage, the story behind the name. So there's a Marquez project website you can go to, and you'll find it on the OpenLineage website as well. And it's a good way to look at your events, right? In a way, it builds the lineage graph. You can inspect the metadata and see what they look like.
We have this repo, and now we're consuming from this repo. We're talking about contributing to it a lot. And I guess first let's talk about the old days before OpenLineage and producing and consuming. So we have Lineage producers, right? Like, what are some examples of that?
Right. So some examples you would have Airflow is a very popular one, right? Spark, various BI tools like Snowflake or BigQuery, all the things.
And then we have consumers, and it's Lineage consumers.
Yeah, so the consumers, you would have things like Marquez is one, right? So there's several open source projects that get interest in Lineage, like Data Hub. There are vendors like Atlan or Colibra or Datadog who consume Lineage to provide either data observability or governance, compliance use case. So in the old days, all the Lineage consumers, they would go and they would reverse engineer all those producers, right? Because they all speak a slightly different language. They might be open source or not. And they would create their own integration for each of them, right? And the downside of that, as a customer or as a user, every time you want to try a different tool, you need to restart the whole integration, right? And it's also fairly brittle, right? Because when you reverse engineer the producers, they may change at any time. If they change the way they work, they break your integration, you have to start over. So it's kind of it's a lot of work. And it's a moving target that you have to constantly keep up with the changes to keep things, right?
If any one of the boxes changes anything, then all of its integrations need to be rewritten.
Yeah, so it's kind of, and so you see, like mathematically, there's a quadratic problem, right? Like it's kind of a nice parabola going up. The more, every time you add a box, it keeps becoming worse and worse quadratically. And so if you erase all of that, now we have OpenLineage in the middle. And the simplification is like, we agree as an ecosystem, as an industry, right, on a common way to do this. So now if we get back to this, my definition, it becomes a linear problem. Instead of being quadratic, it linearly increases with a number of players, because now each participant just has to go against the spec, right? So, and we all agree, we all speak the same language. And once you do that, if you produce OpenLineage, all the consumers of OpenLineage understand it. And if you consume all of OpenLineage, you can consume from all the producers of OpenLineage, right? So there's kind of the value of creating an ecosystem and getting all together as an industry, right? As an ecosystem, and agreeing on how you do that so that we all benefits, right? And it's also remove the brittleness, because now we have a shared contract to go against, right? Like everybody can say, okay, we adhere to this and we guarantee it's not changing. You don't have to reverse engineering my specific way of doing it.
If your organization adds OpenLineage, what does that unlock for you in terms of what you're able to do now that you weren't able to do
So
before?
one of the benefits, it's once you instrumenting your jobs with OpenLineage, you get this flexibility of trying different tools. It used to be that you would spend a lot of energy instrumenting with one lineage consumer, right? Like maybe you're interested in data observability or maybe in compliance. And then if you want to do something else, you have to start over. So either you kind of try to find one of those providers that maybe solve all your problems. And usually there's a whole variety of use cases around Lineage, or you end up having to redo that. So the high friction to try new different things. The advantage with the OpenLineage, we're creating this ecosystem, it's really easy to try new things. And typically you might use more than one vendors, because when, like, again, we get back to when you talk to different people, you will have a different definition of Lineage, because people who care about compliance, they have a very specific vision of this. And so you would have products that are very specifically geared towards being compliant with what you're doing with your data. And there are other tools that are focusing on, okay, I want data reliability. My team is responsible for delivering data. Maybe it's a dashboard. Maybe you're producing models for AI-powered features, right? So all of those things, like you care more of reliability. So you might use different toolings, right? Like a data observability tooling to ensure you can be on call and do all those things. So typically, it's not only you might try the better product, but you might have multiple products you're using that all rely on collecting lineage. And so that's kind of, you get a lot of value for everyone, right? For a vendor, it's easy onboarding, like the customer can easily try me. For the customer, it's, I can easily try new things and I'm not locked in anyone, right? I don't have like to have this big effort to big investment to try a vendor, right? It's easier to try things. So it's kind of, that's how you make standards work, right? It's a win-win situation. Like getting, that's what powers, right? Because it's work, right? You need to talk to other people and get to an agreement. The motivation comes, but well, it makes everybody's life easier, right? So we all benefit from creating momentum around this. If you're responsible for data, you want to understand what's upstream of you, because changing upstream of you will impact your ability to deliver reliable data, right? You're consuming data that's produced by other people. So you're relying on other teams, right? You're reading data, but the data is produced by a job that's maintained by a team. So understanding who owns it, right? Root cause, if it's broken, who to talk to, how to fix it. And the flip side of this is when you change something, whenever you change something, you might impact a downstream job, right? So there's this impact analysis, which is, I want to know that I'm not going to break someone downstream of me, right? So for that, you need to know who are the downstream jobs, who owns them, and somewhat what they're doing, and how your change is impacting them, and whether you should talk to them first, right? Or if it's a safe change, what you can do.
Cool. What would you like to end it on?
Well, I guess we can talk a bit about how we're using it at Datadog, right?
Oh, I love that. Yeah.
Right, because so we talk about the ecosystem and the value to the ecosystem. And at Datadog, we're doing a few things, right? So of course, Datadog is focusing more on the data reliability, data quality aspect of things, right? So one aspect is data job monitoring. It's kind of understanding whether things are running on time, if they're becoming slower over time, if they're becoming too costly over time, right? And if you need to improve performance. So part of this, if in the data delivery, there's a notion of freshness, right? Like if you're posting a daily dashboard, like I think many data people have experienced, like if the dashboards for sales, you have the head of sales that's going to look at it every morning, first thing. And if it doesn't look right, they're going to text.
Somebody's in trouble.
Dashboard's wrong. Eventually a data engineer will get paged. And so there's a timeliness to it, right? If things are late, it also has impact, right? So data jobs monitoring is kind of focusing on how long it takes, how many resources it's doing, is it running properly, and so on. And so we use OpenLineage to get more insights in the dependencies, right? Like, because something's delayed, you don't necessarily know which steps is taking longer or which step has been delayed, how we troubleshoot this, how we fix this. Data quality monitoring is another aspect. Like we talked about, if something is just broken and not running, right, you know about it, right? You get errors, you get probably notifications and so on. When something's wrong and sends bad data along, it's harder to tell unless you explicitly define ways to recognize good data versus bad data, right? There's things that are going to be obvious, like maybe we have too many nulls, right? Or I think that might be a little more subtle, or like, hey, we need to look at the distribution of the values in this column. Making sure not only that the data gets delivered in a timely way, but we didn't break something in the correctness of the data, right? Like having some mechanism to verify that the data looks correct, or at least there's no obvious error in there that would propagate, and maybe until your billing system or anything AI powered, right? Like if you have a model that if you're serving ads or if you're making recommendations for your users, if bad data propagates to it and recommendations makes no sense to your user, it's direct impact on your product, right? So they kind of, not all jobs are the same, not all data sets are the same. Some are more important than others, right? And so it's really important to capture them. And I think the last thing is just understanding the lineage graph, right? Like being able to see the lineage graph and being able to reason about it. Does it look good? Like, do we have sensible dependencies? Like sometimes, we layer data sets, right? Like because you have the raw data you collect, and if you're doing analytics, you might want to remove spam, like outliers from your data, because you might have bots and things like, so you don't want to measure customer engagement on your website, including the bots. Often you have to be careful where you have certain data sets you're supposed to use to do certain things and some that are not, right? Like you don't use the raw event data from your website. You can filter out things that you want to ignore in engagement metric, for example. So like just understanding how things depend on each other and make sure is correct is also an important aspect. Sometimes it could be a performance or cost optimization use case. So just understanding the lineage graph. Like for example, if multiple teams do the same processing again, like seeing the lineage graph helps you a bit troubleshoot, like simplify, remove complexity, remove duplication, have common models that can be shared and advertised, right? So it's understanding that is important too.
This has been such an enjoyable discussion. Thank you so much for sharing your time and your expertise today. As a reminder, can you tell folks where to go to find more information about OpenLineage?
Yeah, so you can go on the OpenLineage website. So you have it like at the top right of your board, openlineage.io. You'll find documentation, you find link to the ecosystem. There's the ecosystem page that shows you about all the consumers, producers. If you want to participate in the community, there's a monthly meeting, there's a Slack, right? The Slack, OpenLineage Slack that you'll find a link on the website is the best way to interact with the community. And there's a monthly meeting where people can either present things that's done, or their announcements about new releases, or it's also a good place if you're stuck, if you have questions, you want to suggest improvements. That's a good way to speak with the community, not just like being in this asynchronous discussion. And of course, there's GitHub for issues, tickets.
Well, thanks again. This has been incredibly fun. Have a wonderful rest of your day. Thank you, Julien.
You.
Thanks.
Bye-bye.
Bye.